All right, so if we take a look, here's what we're doing. I told you what's left in this chapter, this prerequisite chapter, are inequalities. And how do I solve inequalities? How do we work our way through quadratic, polynomial, rational? Same types of equations, but now the inequality version. Today's lesson is just hopefully some of the basics. There will be a few new things, I'm guessing, but for the most part, I think it's more just a refresher today than anything. First one, we're going to start off with just basic linear inequalities. Just some reminders. First question, when do I switch the inequality symbol when you're solving? When you are multiplying or dividing by a negative. Anytime you multiply both sides of an inequality or divide both sides by a negative, the inequality sign switches. And I'll show you on the whiteboard why. Okay, it's a very simple reason, and it comes down to the rules for positive numbers are different than the rules for negative numbers. Like I said, the positive rules versus the negative rules. If I put two numbers on the board up here, let's say I put 3 and 10. On the positive side, 10 is bigger than 3. But now, if I multiply or divide both of those by a negative 1, they'll switch it to a negative 3 and a negative 10. Which one's bigger? Negative 3, because it's less negative. That's why I'm saying the rules are switching. Okay, so that's why when you multiply or divide by a negative, that's the reasoning behind it. Okay, the rules for negative versus rules for positive. All right, with that being said, here's your first basic inequality where we're going to execute this. So solve this just like that was an equal sign. Okay? Pretend like there's an equal sign in there and go through and solve it as if it was an equation. So first step, I'm going to take the 4 and distribute. We get negative 3x less than 4x plus 8. You got x's on both sides of the inequality. Get them on the same side. So I'm going to subtract the 4x over here to the left. We get a negative 7x less than 8. And last step then, divide both sides by a negative 7. And now, yep, you beat me to it. Now, because I'm dividing by a negative 7, I need to flip the inequality symbol. So instead of x being less than some number, now it's actually going to be x is greater than. Negative 8/7 is not a very nice number, so just leave it as negative 8/7. Okay? As always, if you can reduce, you should. In this case, we can't, so we'll just leave it alone. So you solve inequalities pretty much the same way you solve equations. The one difference is you got to remember when to flip the inequality symbol. Okay? Now, one of the big differences between an equation versus an inequality. An equation, you get one answer or two answers or something along those lines, depending on the equation. In inequality, you actually have infinitely many answers. Any value that's bigger than negative 8/7 is going to work if you plug it back into that inequality. It's going to form a true statement. So there are all kinds of answers that we have. We're going to put our answers, when you solve, you're going to get an answer in inequality notation. There's two other ways I want you to represent your answers. Okay? One of them we said is a graph. And I don't mean a graph like an XY graph, because there are no y's, we just have x's. Which means the graph for this one is just a number line. Okay, so let's put that down. And we'll refresh our memory on this as well. So in this problem, this negative 8/7 is what's called a critical point. Okay, it's one of the main points that we're taking a look at. There's two things I always want you to put on your number line. Any critical points and 0. Okay, so in this case, we'll just go through and put, let's say negative 8/7 is right there. And we'll put 0 over here. All right, let's see what you remember. Open dot or closed dot at negative 8/7?
Closed. It's got to be closed. No, it's closed.
I want the values that are strictly greater than negative 8/7, so not including that number, which means Let me switch colors here for a second.
It's gonna be open. Haha.
Open. Open means not including that point. A closed dot means that point is included. Okay? And then where are the numbers bigger than negative 8/7? To the left or to the right?
To the right.
Yeah. So we shade to the right, including the arrow, signifying that this is going to keep going forever and ever and ever. It'll go to infinity. Okay? It will never stop. So there's one way that I want you to show your answers. Okay? Inequality along with a number line. Here's possibly the new method. I talked at least a little bit about this, I know, last year in Algebra 2, but I'm not sure that all of the Algebra 2 teachers did, so this might be new. Okay? And even if you had me, we didn't spend a lot of time on it, so it's not something you might not have it perfected either. So if we take a look, negative 8/7, and we're going to do what's called interval notation, which basically is saying over what interval of x values will work. We always work from smallest to biggest, so left to right on our number line. So the smallest number we're taking a look at is negative 8/7. And I said it purposefully when we were talking about the number line. If I keep going, where's it going? Forever. Infinity. Okay, so it's going to look like an ordered pair. It's not an ordered pair. It's saying we're starting at negative 8/7 and we're going to infinity. Now we have to add some symbols. We're not including negative 8/7, therefore we put a parenthesis. If you're not including the value, it's a parenthesis in interval notation. If you are including it, you'd put a bracket. Okay? Which again, on the next slide, I have it. I have it summarized when you use which one. Parenthesis for not including, bracket for including. Whenever you see an infinity symbol, whether it's positive infinity or negative infinity, you always put a parenthesis. Anybody tell me why? We said a bracket means you're including that value, right? Can I include infinity? It's not a number. Infinity is a concept. So you can't include you are not able to include a concept, okay? Unless it's an actual number that you can include. That's what you have. So here is your interval notation on this one. This says all the values from negative 8/7 to infinity will work. Not including either of those. So let me summarize the whole open circle, closed dot, parenthesis, bracket, so you have it all in one spot. Here's what you have. So when you solve an inequality, it's going to be an inequality notation. So you'll have, whenever you have strictly less than or strictly greater than, you will have an open dot on the number line and parentheses in interval notation. Those go together. Okay? Anytime you're not including a specific point. Open dot and parentheses in this kind of the three different ways we're going to show our answers. When you are including your answers, greater than or equal to, less than or equal to, then you put a closed dot at that value on the number line, and you put a bracket in interval notation. The bracket means that you're including that value. Okay, that's the mathematical notation for this. So I'll give you a second to write that down so you've got it to refer back to. Like I said, I'm guessing the interval notation is mostly new to pretty much everybody. Any questions so far? All right. So that's kind of basic inequality refreshers along with a little bit of new stuff. Now we're going to kind of add to the next part. So we're going to take a look now at what are called either double inequalities or compound inequalities. The only reason I put this stuff up here in orange, we're going to keep the inequality balanced. We're going to switch signs if needed, just things to remember, things to think about. And here is the actual problem we're going to take a look at. A Double or compound inequality is when you have two inequality symbols. Meaning, technically, there's two inequalities there. So I told you before, and I said technically there's two inequalities. Here they are. If I cover up the first part, there's one inequality when it's less than 5. If I cover up the end, there's the other inequality. So realistically, if you wanted to, you could split this into two parts and solve them separately. I'm not going to because I actually think it's easy enough that I don't need to. We just got to make sure we keep things balanced. We're going to solve it like an equation. But just like an equation, when we have anything you do to one side, you do the same thing to the other to keep it balanced. Well, we now have 3 parts. We've got left, middle, and right. Therefore, you got to do everything to all 3. So if I'm solving for x, if I want to get x by itself, what's the first thing we would do?
Multiply by 2.
Yeah, we could get a common denominator. Instead, we've been working on clearing fractions. Let's clear the fraction. I'm going to multiply everything by 2. 0 times 2 still gives me 0. The middle fraction then, it cancels the 2 out, leaving you with x plus 3. And the last part, we have 10. Now, what's the last step? Now I got to get x by itself, so I need to subtract the 3, but I subtract the 3 from all 3 spots. In the middle, I'll subtract the 3 to get x by itself, but then I have to do the same thing on the left and the right. -3 less than or equal to x less than 7. There's your inequality notation right there. There's your answer for your inequality notation. Any questions on that? Anything not make sense? That's it for this one so far. We're not done with the problem. We still got to put the number line in the interval notation, but that's it in terms of solving. Yeah, we got x by itself. There's 2 types of compound inequalities. There's and there's or. This, I'm going to put it down, is what's called an and type of inequality. Here's why. My answers are bigger than one number and at the same time less than another. Your answers are always sandwiched between 2 values. Okay? Bigger than one and at the same time less than something else. The next and last example will be an or one, and I'll show you the difference between the 2. All right, so let's take a look at the number line. Let's put that over here. Again, I'm going to put the critical points down, in this case -3 and 7. And then we'll also put 0 on there. All right, -3, open dot or closed dot? Closed, because now I am including -3. How about at 7?
Open.
That one's open. We're not including that. And where do I shade?
You just draw one between those 2.
Right in the middle. X is sandwiched between -3 and 7. All of the numbers between those 2 will work in our original inequality. There's your answers right there. Everything between -3 and 7, including -3 but not including 7, will work out. If I then go back and write this as interval notation. Again, we said we're going from left to right. Smallest solution, bless you, smallest solution first, followed by up to the biggest solution. So we're going to go from -3 to 7. What do I put at -3, Eddie? Bracket, because we're including that. And what do I put at 7? Parentheses, because I'm not including that. There's your interval notation. Okay? From -3 to 7, including -3, but not including 7. Okay? How are we doing so far? Are we doing okay? All right, I've got one more example for you. Here we did an and type of compound inequality, Now we're going to do an or type of compound inequality. Again, stuff up top is just a reminder. Keep everything balanced. Switch the sign if you need to. Okay, don't forget about that. That's one thing you got to always remember with inequalities. This one, because we have an or, you're going to actually solve these as two separate inequalities. And then we'll put the answers together on one number line. So on the left side, subtract the 2. We get 3x less than negative 12. Divide by 3. I get x is less than negative 4. There's one part. Or, now we solve the other one to see what the other portion is going to be. Add the 4 over. 2x greater than or equal to 0. Divide by 2. I get x greater than or equal to 0. There's your two parts. Anybody tell me why this is an or versus an and? Yeah. You can't pick a number that's less than negative 4 and bigger than 0 at the same time. There are no numbers that are less than something negative and positive at the same time. Okay, that's why it's an or. So when you do your number line, okay, I saw Nick do it before, it's no longer the middle, now it's the two ends. Okay, so if we put our number line down, we've got negative 4, we've got 0, not including negative 4, open circle, and all the numbers that are less than negative 4 are to the left. So there's that part of it. Okay, going to negative infinity. And then on the other side, including 0 and everything positive from there, going to positive infinity. Okay. And type of compound inequalities are always in the middle. Or is always on the two ends. Okay. Let's put this in interval notation then as well. Let's represent that number line as an interval. So like I told you before, starting from the smallest, going to the biggest. Well, this is pointing, where's this going? Negative infinity, that's where we're starting then. And what do I put, bracket or parenthesis? Parenthesis, we can't include something that's not a number. Okay? We're going from negative infinity up to negative 4. Bracket or parenthesis? Parenthesis. Okay? That interval is this part of the number line. Okay? That interval is that part of the number line. Now let's skip to the next one. We're going to put another interval down. Now we start up at 0, and where do I go? To infinity. Not including infinity, because you can't, but including 0. So we put a bracket. And here is the last thing we need. The mathematical symbol for or is it's called a union. It's a little u. That's your mathematical symbol for or. Okay? So if you see that, that means here's one set of answers, or here's the other set of answers. Okay. How we doing? We feeling okay? Like I said, mostly review, a little bit of new stuff today, hopefully. What I have for you then is a very short assignment. All of like 5 questions. Okay? If you have not, by the way, been getting homework turned in, like I said, get that turned in. Most people have it done. There are a few people that have not been real good about it, so let's make sure that gets taken care of, and then we'll go from there. Let me hand this out, and that is all I have for you.